Today we'll be discussing on electrical testing. Electrical testing will be carrying out electrical testing in installation works while or probably when we finish with the installation on site, we have to carry out certain tests to ensure that what we've carried out proves or it conforms with certain requirements and certain codes. This is to prove the quality of work that is being installed on site. And then also we'll carry out commissioning, which is to prove that the system operates and performs to the design intent or specification of the project. So we'll be basing on two different codes. I'm talking of the BS7671 and QCS 2014. QCS 2014 we're focusing on section 21 part 23, which will be discussed. So when you go through this section of the QCS 2014, you'll find series of tests that have been mentioned, which we have to carry out all these different tests once we are done with our electrical installation work. So they come in the different parts when we are carrying out electrical installation works. Like for example, we have the dead test and we have the live test. So basically I'll be dividing this testing works into two different parts, which is a live test and a dead test. So the dead test, I'll start with the dead test. So the dead test is a test which is being carried out when electrical supply is not given to the installation. Supposing we have an electrical DB or an electrical panel board, which we have to carry out testing on this panel board. So the test that you'll be carrying out on this panel board when electricity is not supplied to this panel board will be called the dead test. While when you supply electricity to this panel board, the test you'll be carrying out will be the live test. So the reason why we need to understand this is so we get to understand the safety measures that we have to carry out, or the precautionary measures that we have to carry out when we are performing these different tests. And then also we have to submit method statements, which also we have to submit as well the ITP, which is an inspection test plan, which in there we will get some checklists which will be attached to them, which we have to make sure we follow these different points that we're mentioning in the checklist to carry out the different testings which we have to be explaining now in this part of the lesson. As per BS7671, we have also different sets of tests which we will be carrying out, which also we will find almost similar tests which are found in the BS7671. It also we will find them in QCS 2014, section 21, part 23. Okay, before we carry out any test, we have to ensure that our measuring equipment or our measuring equipments that we are using to carry out these tests are all calibrated. Okay, calibration is a process or configuring an instrument to provide a result which is acceptable or an acceptable range. So we have to make sure that all our measuring equipment or instruments are all calibrated before we are carrying out the different tests that we need to carry out in the electrical installation work. So as per BS7671, like I did mention, I will divide the different tests into two different parts, which are the dead test and the live test. So BS7671, which I have to follow, and then also for QCS 2014, we find these different tests that I'll be mentioning in the BS7671, which will also be found in the different tests which I'll mention as we keep moving. Okay, the first test will be, I will start with the dead test. Start with the dead test. The first test will be continuity test. Continuity test is a test to ensure that we will have electrons flowing from one point to another, or we'll have current flowing from one point going to another point. So I'll give an example whereby we have a DB or a distribution board which is at this end, then we have a wire or a cable which is being run from a DB coming to a socket outlet. So in this case now we have to carry out continuity test to ensure that we will have electrons flowing from one point to the other point, or having currents flowing from one point to the other point. So we'll be carrying out this test using a measuring equipment, a multimeter we'll be using to carry out this test. So we'll ensure that and before carrying out this test, I'll give an example of whereby we have single phase supply, which is a phase and the neutral. For the phase and the neutral, one end, and then we are testing on the other end. So what we have to do is short this end and then test the continuity from this other test, from this other end now using our multimeter. So this will ensure that we have continuity, and then we have to record it in our test sheet. So the next test, as per VS 7671, will be insulation resistance test. Resistance test. Insulation resistance test should be carried out to ensure that we will not have any joint between two different conductors of different polarities, and we should have a standard value which should not be greater than 1 mega ohm. So anything less than 1 mega ohm will be acceptable. Now anything anything greater than 1 mega ohm which will be acceptable. So less than 1 mega ohm will not be acceptable. So we'll carry out this test using a mega tester. Or probably you might also be using a multifunctional tester. In this case, we'll be talking about fluke tester. So for a mega tester, which we might be talking of an MIT series, whereby we have series of scales that we have to select the amount of voltage which will be injected in that circuit before we are carrying out this test. So if you go through QCS 2014, it clearly states that we have to make sure that when we are selecting our range for this test, we should ensure that the amount of voltage we are putting on the scale should be twice the nominal voltage of the supply or of the panel board which is under test. Supposing we have 240 volt panel board, or we have a 415 volt panel board, so we have to ensure that for a 240 volt panel board, we have to ensure that our selection range which we have to select on our mega tester, which is an insulation resistance tester, should be greater than twice the nominal voltage. So in this case, you normally see we select 500 volt, which we are injecting on that circuit. So we have to make sure that we carry out this test with safety, or with safety measures, because this is an amount of voltage which we are injecting in the circuit. This will be DC. So 500 volt DC will be injected into the circuit, so we have to follow precautionary measures when we are carrying out this test. It's very important to understand. Trained personnel should carry out this test. The next now we're talking of continuity of final ring circuit, number 3. Final ring circuit. For final ring circuit, give an example of whereby we have a series of socket outlet. They are all connected together. And then from here goes to the DB. From here also comes to the DB. So in this case, this is a ring circuit. So continuity for final ring circuit, we have to also ensure it's the same as continuity that we are carrying out, but in this case, we will have two supplies that are leaving from the socket outlet that are coming to the DB. So we have to short one end and then test the other end. So the wires or the cables that we are shorting together on one end should be the same wires that we are testing on the other end. This is very important to know while we are magnetic circuit. So the next test that we'll be carrying out now will be polarity test. Now we move now to live test. Number 4 now will be polarity test. So polarity test is to ensure that we have all the different wires which we've connected or we've placed in our panel board. They are all connected properly. I'll give an example of arrow, Y, B phases. So we have the red wire, the yellow wire, and the blue conductors are all connected accordingly. So to carry out this test now, we have to make sure that we test the amount of voltage that we find between the arrow phase and the Y phase, between the arrow phase and the B phase, between the Y phase and the B phase, and between the Y phase and the arrow phase. And then we will ensure that we have 415 volt 415 volt. We have to ensure that we get it when we are carrying out these different tests between the arrow phase, Y phase, arrow phase, B phase, Y phase. That is all the different live phases. So we have to ensure that we have a voltage of 415 volt. We record down in our checklist as well. And then also between the arrow phase and the neutral, between the Y phase and the neutral, and between the B phase and the neutral, we should have a voltage of 240 volt to ensure that all the polarities or all the wires that we've connected are properly connected. It's very important to understand. So the next test that we'll be carrying out now will be the electrode test, number 5, as per BS 7671. Electrode test is a test which will be carried out when we've done already our installation of the head pit is already done. We put our head rod and then we carry out this test. So normally this test we have to carry out using our head electrode tester to carry out this test, and the value should not be greater than 1 ohm. As per as per QCS 2014, it states that we should have a value of less than 1 ohm of a resistance to ensure that we have a good earth. Should be less than 1 ohm. So anything greater than 1 ohm will not be acceptable. So we carry out this test by ensuring that we will have an electrode that we'll put under test on the ground. This is the electrode under test, and then we have 2 additional electrodes which we have to put under the ground as well. So what we have to do here is, here will be the potential electrode and here will be the current electrode. So this is the electrode which will be under test. So we have to measure now using our head electrode tester. We'll take our head props, put one link here, put the potential link here, and then put the current link here. So notice that in our tester we mostly have P1, P1, C1, and then we have P2, C2. So in this case now, these two will be linked together and connected to the electrode under test, where the P2 will be connected to the potential electrode, then the C2 will be connected to the current electrode. So we carry out this test first, where we place a distance of say maybe 30 meters away from the electrode under test, and then half the distance we should place between the electrode under test and the potential electrode. We'll put the current electrode as well. So after putting this, we'll take down the first readings, and then we reduce the distance by maybe between 3 meters to 5 meters, and then we bring it closer to the electrode under test. We take another reading, then we take it behind as well, which is between 3 to 5 meters as is again. We take it behind, and then we record again another reading. Then we take another average of this reading compared with the different reading that we have to ensure that we have earth resistance of 1 less than 1 ohm, which will be accepted by QCS 2014. So you notice that for earth resistance, having a 0 ohm resistance for earth, which is very good, which is found impossible to have 0 ohm. So actually, we go through different international standards, you hardly find a standard which is put as maybe an earth resistance. Some other books you might find maybe 5 ohm, but as per QCS 2014, which is 1 ohm, less than 1 ohm, sorry. So any resistance that you have greater than 1 ohm would not be acceptable. The next test that we'll carry out now will be the earth for loop impedance test. Number 6 will be the earth for loop impedance test.